we are going to the chapter 5. That's why I want to stop yesterday, because I want you guys to have time to catch up. Hopefully you all kind of catching up, okay? The chapter 5 is a little bit different. Remember, we've been looking at the polynomials mainly. We have the law. Now, chapter 5, we are doing specifically logarithmic and exponential and other transcendental functions. That's the only thing we're going to work on derivatives and anti-derivatives. Okay, so chapter 5 is about specific functions. Only work with the log and exponentials, and transcendental function is a trigonometry functions in a way. Okay, so we're going to work on those. All right, so natural log and function of differentiation. So develop and use properties of a natural logarithmic function. So we are going to look at properties of natural and log functions, understand the definition of number E, and find a derivative of functions involving a natural log functions. Natural log functions. So this is what the general power rule that we know how. Remember, we do this, right? You add one more power and divide it by the power of that become your general power rule of anti-derivative, right? We know that. Okay, so, but we're going to have a problem when n equal to -1 power. Okay, so let's look at this one. If I have this, all right, so if I use general rule power, so what's the answer then? The answer should be x to the -1, and I'll add 1, and everything divided by -1 plus, add 1, and then I do plus c. Okay, now look at what happened to your denominator. Does everybody see we have a problem? When we evaluating x to the -1 power using a power rule, we are going to have a problem. Mainly look at my denominator. That become a 0. So can I have a 0 in the denominator? No. So I cannot just do this way anymore. If I have a function that has a -1 power, the normal general power rule does not work. Okay, that's why we're going to talk about the log functions and how would you take a derivative of a log functions, or how do you find a anti-derivative of log functions. That's why we have a specific chapter 5. It's only going to talk about those, the specific functions. So definition of natural log. Okay, definition of natural log. That's what they say. If you see this is exactly the same as, that's what that means, right? -1 power. That case, okay, when you take anti-derivative, you get this, natural log of x. The domain of a natural log function is called all positive real numbers. So let's look at it, what it looks like. This is what 1/t looks like. The graph of 1/t looks like a descending function. All right. So as you know, you get more and more, depends on what you choose to be your upper bound of x, right? Your upper bound of x. In this case is 1. And this case is over here, whatever the number that is. Right? That's what log function looks like. 1/t, 1/x, this is what it looks like. To sketch a graph of y equal natural log of x, okay, natural log of x, it looks like this. Okay, natural log of x, you get this when natural log of 1 give you 1. That's why, give you 0. So that's why right here is 1, 0. When x equal to 1, your y value equal to 0. So your graph looks like that. That's what natural log looks like. And this one over here, that's 1/x. They're inverse. Do you see it, the difference? This one goes upward. Okay, and look at this 1/x. They're going what? downward. They are inverse to each other. Okay, oh, one more. Okay, properties of natural log. I want you to listen carefully about the properties. The properties of natural log is a domain is 0 to infinity. The range is negative infinity to positive infinity. You see it? The range is negative infinity to positive infinity. But the domain starts where? Domain starts right here, 0, and then goes to where? Positive infinity. So that's why you said domain is 0 to positive infinity, but the range is every real number, negative infinity to positive infinity. Number 2, the function is continuous. It's increasing and 1 to 1. As you can see right here, it's increasing. Every part of this is increasing. Okay, and they have their 1 to 1 function, which means every x has 1 y values. And every y has 1 x values. So that's 1 to 1 functions. In the graph, it's concave down. As you can see, this is concave down. This is called concave down, and this is called what? Concave up. So natural log is a concave down. Oh, excuse me, down. All right. Now, I want you to memorize this or write this down so when you do your homework problem, you know what to do. The log has properties. So natural log of 1 is 0. And when you have a natural log of a times b, when you have a times b, you can make it into 2 terms by natural log of a plus natural log of b. Next one, when you have a natural log a to the n is your power. You can bring down the n in the front, that become a coefficient of your natural log. So n times natural log of a. Next one, when you have natural log a divided by b, you can make it into 2 terms, natural log of a minus natural log of b. I want you to memorize this so it'll be easy on you. And this is what, actually you have learned this in your college algebra class. In case you forgot, just refresh your memory so you can do your homework problem, because you will use this to do your derivatives and anti-derivatives. Okay, for right now, we're just gonna practice. So if I give you natural log 10 divided by 9, you can rewrite it as natural log minus natural log 4. That's a property 4. If you have this natural log of square root of 3x plus 2, you can rewrite that as half power, because square root is the same as half power. So it's going to be 1/2 in the front. All right, next one. If I give you this natural log of 6x divided by 5, first thing you're going to make it into division into minus, making it 2 parts. Now looking at the 6x. 6x is the same as 6 times x. So if it's time, you can make it into a plus. So when you completely expand it, this is what you have. Does everybody see it? This part right here, you can make it into this when you completely expand it. The 6 times x give you natural log x plus natural log of x. Natural log of 6 plus natural log of x. And the division give you the minus part right here. All right. Any questions with this example? Anybody have any questions with this example? Does everybody understand what's going on? Yeah. Let's look at the little complicated one. Next one. Natural log of, look at the numerator. Numerator has x squared plus 3 squared. And the denominator has x times cubic root of x squared plus 1. So first thing first, whenever you see a division, make that into 2 parts by making a minus 2 part. Numerator part minus denominator. Everybody see it? That's your denominator. All right, next thing. And when I use other properties of natural log, since you have a 2, the power of a 2, you can bring it down in the front. So now you have that become a coefficient. Next one. Over here, you got to rewrite this problem to be what? 1/3. So I'm going to just rewrite this one. That would be natural log x times x squared. You have a multiplication. So you can make it into 2 parts as addition problem. That's why you have this addition right here. That came from over there. That become an addition problem. That's why you have natural log of x, and you have this part, which is that one right there. Right. Is everybody following me? All right, so this is a very good problem. Like this example D uses almost all the properties of natural log. All right, so now I'm gonna distribute the negative power. So negative natural log of x, negative of this. Only thing I have to do is make sure that I bring this one to where? In the front. So I'm done. You just finished. So you have this problem. You can make it into that. Because you want to take derivative of this individual easy problem instead of this complicated problem. That is why we want to use properties of natural log, because when we take a derivatives, we don't want to take derivative of this. This is too complicated. It's easy to take derivative of this. All right, that is why we want to use the log expansions. You expand your log, so it's easy for you to take derivatives and easy to calculate. All right, so now natural log number e. So number e, the natural log e is a number. All right, it's a irrational number. Natural log, when you put it in, this is what your number is, which we usually chop it right here, 2.718. But anyway, natural log is just a number. Okay, it's based on number. So when you see again, your graph looks like, so natural log of e is the same thing. It's a natural log of e give you 1. Okay. Another one, in this case, your upper limit is e. All right, then you get natural log of e is equal to 1/t, which is give you 1. That's the definition. Calculator to just find it, that's fine. Okay, but I think on your homework problem, they're gonna ask you using, I need to probably see it. I will look at the homework problem, because this one, actually you can just plug in your calculator and get all that answers. So but out of your homework problem, I'm gonna ask you, say natural log is equal to 0.693. And then they're gonna ask you what is natural log of 8. Okay, then you're gonna say, okay, that means natural log of 2 to the 3. And then I'm gonna, then that's the same as 3 times natural log of 2, and then it'll be 3 times 0.6. Your homework problem may have this kind of problem. We want to make sure that you understand how to expand natural log or logarithm. So you got a natural log of 8, you can make it into this, because 8 is the same as 2 to the 3rd, and you can find this problem. It's a given this. You can look into that. That's the reason that we learn about expanding the compact log or natural log to use up the 3 terms or 2 terms of different simple terms. Okay, so let u be a differentiable function. Okay, natural log of x, derivative of natural log of x, same as 1/x. X has to be positive. X has to be a positive number. Remember, the graph looks like this. right? So it's only a positive number. There's no negative number. Log of a u, in this case, u means complex number of functions, okay? In that case, you need to do 1 over u, du and dx. So we're going to have a u prime over u. So let me give you an example so you know what I'm talking about. So you have this. Derivative of a natural log of a 2x is, remember this is u. So you're going to say u is okay, u is 2x. What is u prime then? It's a 2, isn't it? Right? Well, you can call it u prime or you can say du, whichever, okay? That means 2. That is why your answer is u prime goes to numerator and u goes to denominator. So you have 2 over 2x, which gives you 1 over x. So derivative of natural log of 2x is the same as 1 over x. Next one. If they give you this, the first thing you need to write down as that as your u. What's u prime? What du is what? 2x. That is why you have 2x over x squared plus 1. So actually, finding taking derivatives of a natural log is much easier actually than I would say regular polynomial function, because it's always what? 1 over u and u prime. That's it. In this case right here, then you need to make sure that you separate into 2 terms so it'll be easy on you. All right. So, this case, they use product rule. That's fine. You can do that. Or we can also do what? Oh, I do have to use a product rule, excuse me, because it's not inside a natural log. Okay, so you have to use product rule. So I'm going to call it, that's my f. That's my f is x. F prime is 1. G is equal to natural log of x. G prime is about 1 over x. What product rule is? Product rule is f times g prime plus what? G times f prime. It's pretty much the same, right? So math is always like that. You don't just learn new stuff, but you have to use what? Previous knowledge to the new stuff that you're learning. Like I'm doing finding a derivative of a log, but I still have to use what power rule is, what product rule is, and all that. I have to still use it. So this case, they gave you 2 functions, the 2 factor, x and then natural log of x. So x is your f, natural log of x is your g. You got 2 factor, so you're gonna use the product rule. So that's why you have x times derivative of second factor, and then second times first derivative, which give you this, x times this. Right? By the way, you have to do your homework today, so you have something you can understand this. Like this is not hard, but it's new, so you have to practice right away. All right, this one, we can just simply put that in the front. Okay, so you have this. Okay. U is natural log of x. And then du is what? 1 over x. Okay. So you have this. Right? Wait a minute. Okay, so let me tell you why is this. So we write this problem as okay. So you're gonna do, excuse me. All right, you have that, and you're gonna say, okay, I need to take a derivative of that. Then you're gonna say, okay, the derivative of derivative is this, right? So I'm gonna say, so my answer is to give you, what is my u? Remember the answer is, the definition says, times my u is natural log of x, and you find so this is what I have. They just use the power rule. Oh, class, did you see what I made a mistake? This, how I did over here is exactly wrong. Let me tell you why it's wrong. Oh, this is a very good problem because it's easy to make a mistake. Okay, it is natural log of x to the third is not same as natural log of x to the third. I made a mistake because I was looking at as x to the third, not natural log of x to the third power. Okay, so they're not same. So make a note. Then you got this, u equal to natural log of x and du equal to 1 of x. All right, so we're going to rewrite it. Derivative so I'm going to say, okay, that means 3 times my u is this, natural log x to the square, and du is this. That's why you have this. First, when I did my problem, I made a mistake because I was looking at it like this instead of looking at it like that. Okay? So if I give you this problem, it's asking you to find this problem. All right, so it's asking you, it says, find the derivative of this complicated looking problem. All right, we don't want to take a derivative of a square root with the fractional fractional, what do you call it, quotient functions like this. Okay, we don't want to do that. It's too complicated. So that is why we're going to use properties of a log. The first thing I'm going to look at this and says, okay, let's make this problem a little more easy to handle. So I'm going to say, okay, how about I apply natural log to both parts? Because if I apply natural log to this, I can expand the natural log. So I put the natural log of x, I put the natural log in the left-hand side, left natural log in the right-hand side. So you got that. And because it's natural log and it's a division problem, so I can make it into 2 terms. All right, so numerator minus denominator. Numerator minus denominator. Now you got this 2, so this is the same as 2 log. I'm not going to skip any steps, so you can see it. And then you're going to say, okay, I'm going to put the 2 in the front. And I'm going to make this into square root half power. Right? And then because of that, you can do this half in the front. That can have 1 half. Now I can take a derivative of that. The derivative of this, mu equal to x minus 2, and mu is equal to just 1. We have this. This, and I call it b. And I call that b. And that's b is equal to square root of 1. So that's why you have this. So you just combine them together, and you have this. Almost done. Remember, when you take a derivative of this, you get a y and y prime of that. So you come back over here, and y prime is this. Now, if I replace my y, remember y is this. I'll put that y in. Right? This is a very complicated problem. So I want you to look this one carefully. All right, because if you can do this problem, pretty much all the problems you can do in chapter 5.1 without any problem, because this is most complicated problem. Find the derivative of trigonometry function cosine of x. Okay. By the way, they put the absolute value here because we want to make sure that we only use a positive x. So you have that, and you're going to call u to be cosine x, and then du will be what? Derivative of cosine is what? Negative x, sine negative x. So when you do that, then you get answer this. Negative x, negative sine x divided by cosine x, which is same as negative. Anybody have any questions from today's lesson? So you're done for the, by the way, class, you know, we don't have many days left. I think, let me see, looking at my schedule, so today is the 5th, and our last day is the 25th. So we got little over 2 weeks. Okay, so we need to finish everything. So you don't have a time to like delay for later, because I have to turn it in. All the work will be done by your final exams and your chapter 5 exams. Everything is to be done by 25th. Everything is to be done by 25th, because 26th is Thanksgiving and there's no more school. So you need to make sure, do all your past due assignments, request to me. I will give you grant. I will give you extension. So you request that so you can do all your work. Remember, your homework is about 35% of your grade. Your exam is 40% of your grade. You have 10% for your project. You got 5% for your peer-to-peer reader, peer-to-peer study sessions. Then you got the bonus problem, the algebra bonus problem, which I will get it pretty soon. And then your final exam is 10%. So you need to do all this. Easy for you to get all the work. You can pass this class. So, and some of you guys, not doing your homework problem is not a good idea, because if you're a poor test taker and not doing your homework, there's no way you can pass it. All right. So if you don't have 90 or above in your homework grade, I strongly suggest that you request for extension so you can do those problems again. Okay, so use your time wisely. You got a little over 2 weeks left. And let me remind you one more time, the calculus class is a 5-hour credit class, which means if you fail this one, you will dramatically lower your GPA. So make sure, try not to fail this one by doing all your work and make up your work. Okay. some of you guys still have not turned it in your project. And I also told you I'll give you time to revise your project because some of your project you turned it in is incorrect. Do that so. Like I am willing to give you full credit even though you late. I'm supposed to not, but I am willing to help you out with this. So by next Tuesday, or your project needs to be turned in. And after that, I am not going to upset your project. All right. All right. Now let's look at your homework problems. Okay. Anybody have questions about anything? Does anybody have questions? Okay, so this kind of problem, you can just graph this, so I don't have to do that. About when I was doing your homework problem with you. Okay, so you have to use these definitions. You cannot just plug it in. This in your calculator, you may not get the same answer. And I'm not going to correct. I'm not going to give you manually credit if your answer is not correct because they specifically says use given value. So what they mean by is natural log 0.75. You need to rewrite it as natural log over 3 over 4. 0.75 is the same as 3 over 4. And you're going to say, okay, that's the same as natural log minus natural log of 4. Now I can plug it in these numbers. So natural log of 3 is the same as 1.0986 minus 3 times 0.6931. And you know that's equal to that's how you have to do your problem. If you don't, your answer is going to be incorrect. Problem, you need to just write this problem as what? Extend expressions. To log x minus 3 to 1. And then find the limit of this. Approaching from the positive side. Positive side, something negative. So when you're looking at the can you hear me? Let me look at this problem in a minute. I'm not graphing right, so I will looking at this in a minute. Okay, so please somebody ask me tomorrow this problem as your homework problem. That is number 11. Okay. Definitely do that because I would definitely ask a problem like that. Take a derivative of I'm gonna say my g is equal to 4x squared and my f is equal to natural log 4x. Prime would be 8x. F prime would be to 4x, gives me. So you just plug it in. Remember, g times 4 derivative of that becomes f prime plus f times g. Why I put the wrong, the ones I usually put what I put that to be f prime. That's what I usually do. So I'm gonna just stick with what I usually do. So using the same variable, so you have a f, minus g prime. Just to x. So consider the following. Y equal to 7x squared minus natural log of x. I'm going to only look at between 1 to 7. Find the equation of a tangent line to the graph of function given point x. So they're asking you find a equation of a tangent line. That's another means take a derivative. Tangent line, which is a slope. Okay, that's a slope. Whenever something's a slope, that really means take a first derivative of a given function. So if I take a derivative of this, 7x squared minus natural log of x. So y prime would be 14x minus 1 of x. All right, so given that function at the given point, what's the given point? I want to plug it in, x as 1. So that gives me y prime over 1 gives me 14 times 1 minus, which is 14 minus 1. Now, to find a tangent line, okay, that means y minus y1 times m times x minus x1. Or I can do y equal to mx plus b. And my a here, right? So I'm going to plug in 7 equal to 13 times 1 plus b, which gives me 7 equal to 13 plus b. So b is equal to 7 minus 13, which gives me negative, 6. So I got my equation. I'm going to just plug it in. M is this, b is that. So I got y equal to 13x minus 6. So that's my tangent line. That, because I know you will have a problem like this. So look at this problem so you know how to do it. Implicit derivative means you don't have y equal to and then hold the expression to the x is the right hand side. That's implicit. That's explicit. But now we're going to do implicit derivative because an x and y is mingled together. So we put the derivative as it instead of y equal to something. So taking a derivative over this, natural log of x times y, I can make it natural log of x plus natural log of y. So the derivative of that will be what? That's what we have. And derivative of 4x is simply 4. And 5 is 0. And you can just combine them together. So I have this. I'm going to move everything is not dy dx. Okay. So in that case, I'm going to move the other side. So you have this. So that's it for the today.